All right, there we are. Hey, looky here. It is serverless office hours. This is
Hey,
Ian.
hey everyone.
Tell me how to say it. I always say your name. It's not Massingham.
It is Massingham.
Is
That's
it
right.
really?
Yeah,
Okay.
you got it.
All
First
right,
time.
Massingham. It's not Messingham.
No, Massingham.
Okay.
Yeah.
So when I said Buckingham when I was in England, they said it's not a jumping pig. So okay, so the ham is pronounced. Okay. All right. Well, I'm thrilled to have you here. By the way, do you want to tell them where we are?
Yeah, we are at MongoDB World in the Javits Center in New York City with about 3,500, 4,000 of our friends that are outside the booth here out on the conference floor. This is the first day of MongoDB's conference, so we are here.
Yeah, wait, you can't. We're in like this isolated silence booth, and we're rough and ready. We this is a throwing together audio video, so hopefully you can hear us.
Yeah, we stole this setup from the MongoDB podcast, so we should say thank you to Mike Lynn, who owns all this gear that we have just, I'd say, appropriated here in New York.
That's right. If at any point you see us run out, you'll know what happened.
Yeah, he came back.
yeah, exactly. He came back, and we had to run out. So. First of all, I wanted to say thank you. I got to speak here at MongoDB World. I spoke on MongoDB and why serverless loves MongoDB, and we had a blast with that. So thank you for helping me connect that.
No problem. It's great to have you here.
Oh,
I'm really happy to have AWS here. So
yeah. Good. And it's good to be back in person too. So I will say that we've had a blast kind of getting to speak to people, be in the room, hear people laugh, hear people have fun. Yeah, so definitely. Yeah, it was great time. So, but let's jump in. Today we're going to be talking about. You guys had an announcement today.
We did, yeah. We announced general availability of Atlas Serverless. So we probably want to dig in a little bit and talk a bit about that. But we also have some other integrations with AWS that help AWS users integrate their applications with MongoDB. So it'd be cool to dive into those integrations a little bit as well.
Yeah, let's do the announcement first. And then, so GA, this has been around for a little while.
Yep.
Okay.
Yep.
And it is serverless Atlas. Now, for those who don't know what Atlas is, tell us what Atlas is.
Yeah, so you'll probably know MongoDB's been around a long time. And up to 2006, the only way that you could use MongoDB was to run it yourself on your own infrastructure, on your own premises or on EC2 instances or, on whatever other virtual hosting provider you wanted to run it on, cloud provider you wanted to run it on, of course. And in 2006, we, like a lot of other people, realized that the direction of travel in the industry was databases as cloud managed services. I joined AWS myself a little bit before you in 2013 because I knew that everything would be moving to the cloud. It was kind of a fait accompli in my eyes that most technology would go there. And databases went there pretty quickly. So I came over to MongoDB at the end of last year from AWS. And at that point, Atlas had already been around for a few years. Predictably, it's a cloud managed service for MongoDB. So rather than running your own instances, you provision your Atlas instance, dedicated instances, or now your Atlas serverless endpoint. And you consume all of the features that MongoDB has as a cloud managed service with a consumption-based model.
Yeah. And today you guys went GA with it.
Yeah, we went GA with the serverless version of Atlas, which is, your familiar serverless characteristics. I probably don't need to explain it to you.
I wrote this on, yeah. So those who don't know what it is, here's how I explain it, and see if you guys follow the same model or y'all. So when we talk about serverless at AWS, we say you don't have to patch manage, you don't manage the machines. It scales as needed. Does this scale to zero?
Yep, scales to zero.
That's incredible. That's really cool. And then the third one is security's there. You build in the physical security automatically.
Yep. Yeah, okay. We have that. But I think the other thing is, consumption-based economics. Right. And something that I think is unique to Atlas Serverless is this falling price model. So as you drive more read operations, more I/O through the database, through the data platform, your cost per I/O will fall away. And when you get big, it will cost you about 90% less per operation than it did at the beginning. So rather than have this sort of linear cost line, we have this decreasing, this flattening curve for cost. So scales on demand down to zero, nothing to manage, and then excellent consumption-based economics that come with the service.
Right on, and that's our fourth one is pay for what you use. Which is how I can't use the big words. Consumption-based. Yeah, that's big words. Big words. All right, he's English. He knows the big words. I don't. So but I did get your name right, so that's that's a huge score. Yeah. So okay, so now that we kind of understand what that is, and they announced it's in GA today. Yep. Let's talk about the access patterns. Before we talk about let's talk about the access patterns. What are they?
You mean for data modeling?
Data modeling, or just connecting AWS to.
Okay,
Mongo.
so for connecting AWS to Mongo, I mean, there's three primary mechanisms that customers use to connect serverless applications to MongoDB. With Atlas, and actually with either Atlas Serverless or these dedicated Atlas instances that we have, it's super easy to connect your AWS Lambda functions to an Atlas endpoint, whether that's a serverless endpoint or a traditional endpoint. You can embed our drivers inside your deployment package and run our MongoDB drivers on your Lambda functions.
Okay.
And we support 12 different programming languages, everything from JavaScript to Java to Rust to C#, to Python.
That's an SDK call.
Yeah, exactly right.
All right.
Yeah.
And so that gives you, I'm going to jump into this a little bit, and you can squash it and go, no, Eric, you're wrong, because that happens. But so that gives you some things. One of the things I was talking about today, and one of the patterns is this syncing pattern, the realm, the sync. What's the sync called?
Atlas Sync.
Thank you. Atlas Sync. I kept trying to say active. Atlas Sync. And that handles, so if I'm using Swift or something like that, that SDK is going to handle that syncing for me.
Yeah, that's out on the mobile device. So, you're using that, you can dispense with a traditional API for CRUD operations.
Okay, gotcha.
Different programming model. And there we support commonly used mobile development languages, Swift, Kotlin, Flutter, some others as well.
Okay.
So that's for either syncing onto lightweight mobile edge devices, or building a new kind of API, which is a sync-based API rather than event-driven API. It's a little bit of a different programming model.
Gotcha. Yeah, my bad. So this is for you're right. I absolutely jumped on that. I munched it together. So this for the Lambda, the SDK, for Lambda functions, the SDK helps you communicate.
Yes. So it handles, retry logic, and actually it turns access to data inside MongoDB into something that you do in whatever programming paradigm you're working in. So you'll create a connection object for the endpoint that you're working with by providing a connection string for MongoDB's database inside Atlas.
Okay.
And then you'll work with that connection object natively in JavaScript, in Python, or in whatever other programming language you're using. So one of the things that we would say makes MongoDB a little bit different is you don't have to construct SQL statements as a developer.
Right.
You're operating either using our driver or in some cases using an ODM, an object database mapper.
Right.
And it makes it a much more natural experience for developers that want to work with data in our service. This is why we think MongoDB offers a really big productivity boost for developers, because they get to use all of the expertise and skills that they've developed in, say, C# Link, their query builder, or manipulating objects in JavaScript or Python. But what's happening behind the scenes is you're talking to a MongoDB endpoint and manipulating data inside our database, but no SQL's involved. We've got a different query API, much simpler.
So it's kind of doing the translation for you.
Yeah.
So let me, in that, is that a persistent connection that's maintained?
Yeah.
Okay. So you all handle, so obviously Lambda is not a persistent model, right?
Yeah.
It's a ephemeral model.
Yes.
So you handle the reconnection when it comes back up?
We do, and there's another interface that we also announced general availability of at the show today, which is a HTTPS data API as well.
Nice. Okay.
So depending on what you're doing, you might choose one of those two options. If your Lambda functions really are, on the extremely ephemeral end of the scale, very, very short-lived, don't hang around for a long time, then it might be a better option for you to use our HTTPS data API to manipulate data inside our endpoint. If you're running functions which are a little bit longer lived and maybe perform multiple operations and hang around, then for a few minutes, then you use a traditional driver and you make a driver-based connection. So there's a developer trade-off there.
Right, that makes sense. Yeah, and that's something when we do with SQL servers that we've worked with as well. That's the ephemeral state can be complex, and so it's good that you're helping developers kind of work.
Yeah, and there's an overhead in establishing a driver object, a persistent object for the driver connection, which can add a few milliseconds of latency. And if your operation is just a very simple CRUD operation, then why would you add that latency into your app? It's probably going to degrade the experience for your customers, so you don't need to do that.
But if the trade-off is you're like you said, I'm doing multiple, I'm doing this, then this, then this.
Yeah, then you may benefit from the capabilities that the driver's got built into it.
Okay.
Yeah.
All right, so that's the SDK, the drivers inside of Lambda. What's the next one?
So the next one is Event Bridge. So inside Atlas, we have a change stream capability. So when you make a change to a document inside MongoDB Atlas.
There's folks waving us out there.
you can emit a change event, and those change events can be sent to EventBridge. And as you know, EventBridge can then trigger interactions with other AWS services. So it's for an inbound event-driven model where you want to respond to things that are happening to your data over in MongoDB Atlas.
So that's one of the key things that I talked about today in my session is, not all event-driven architectures are serverless, but all serverless is event-driven.
Yeah.
And we love event-driven. So when you start talking about event-driven, we get very happy. We get very excited because we like events. We don't want to pay for a server to sit around and listen and things like that. So, correct me if I'm wrong. So when I set up a connection with EventBridge, I'm actually setting up a trigger.
Correct.
Right? Okay.
Yep.
So it actually sets up a trigger with the EventBridge as the endpoint.
That's correct. Yeah.
Okay.
Yeah. And of course, that means more than Lambda. It means SQS. It means SNS. It means other services that you could potentially arbitrate. Step functions there.
Step functions.
So it provides a lot more flexibility. We do have our own compute layer, by the way, which is part of Atlas App Services. But customers on AWS obviously want to integrate with the AWS ecosystem. So EventBridge is the gateway that they can use to do that.
So where do you, and I got this question today, and it's an interesting one, and not being as well versed in the functions that y'all do, where do you draw the line? Where do you say, okay, this works well when I jump over? Is it when you want to interact with the AWS services?
When you want to interact with AWS services, but also our own serverless functions are JavaScript only.
Okay.
So, we've got a very constrained set of programming models, languages that can be used. And if you want to write in Rust or Go or Java or all of the other languages that you support in your runtime or trigger containers in Lambda, we obviously don't support that right now.
Right. But for quick server-side processing, that's really
clever. Yeah, well, the triggers are right there inside the Atlas engine, inside the data layer adjacent to Atlas. So if you just want to respond to triggers very, very quickly and do so in JavaScript, then low latency, that's the answer for that.
I'm a huge believer in staying as close to data as you can. Reduce the latency. All right. Okay, so what's the third one?
The third one is Kinesis. So you can target MongoDB Atlas as an endpoint for Kinesis Firehose. So it's sort of the reverse. You're emitting data out of another service, channeling that into Kinesis, and then MongoDB Atlas can be configured as a Kinesis Firehose endpoint. So you're sort of reversing the model. We become the target. So we've got two bidirectional integration models plus the compute integration.
Nice. Okay, so that allows you to ingest massive amounts of data.
Yep.
Okay. All righty. And can you invoke an Atlas function on that?
Yeah, you can invoke a trigger because obviously when you hit Atlas, you're creating an insert event.
Okay.
And that insert event in turn can trigger an Atlas trigger.
Man. Okay. Super cool. Very cool. All right. So those are the three where obviously you can, from a Lambda function, we can do direct SDK, then we can do the EventBridge, and then Kinesis. So let's talk about, I'm going to get a little, unless you have something else you want to jump to, I'm going to get a little personal. So I did a talk today on EventBridge, and I'm going to show you some of the patterns that I use. I want to get your take on it. Be brutally honest, I'm okay with that. This is the first time he has seen this. I'm looking at the mic.
I should also say we have about 4,000 customers that are using triggers within Atlas, and about 10% of that, about 400 customers that are actively using this EventBridge integration as well.
So that I'm about to
we do have quite a lot of usage, and that's of about 35,000 Atlas customers that we have in total.
All right, so I'm going to share my screen. I'm going to share slides. No, I'm not. All right, so like we said, we kind of threw this together real quick, so bear with me as I'm bringing this up here. I'm going to share it and hide it. Let's make sure it comes up. Okay. All right, so now you're seeing there we go. All right, so you should be seeing more than I want you to see. There we go. And my chat's here coming in. All right, there we go. That was professional. Did you see how I did that? Yeah. Okay, so we've got this. This is one of the ones I shared today. And I want to get your take on this. So the idea is, I'm scratch up your laptop. Build that to me. So the idea here is machine learning. You want to be able to tap into machine learning in AWS. Is this a viable pattern, you think?
Yeah, I'd say it's definitely a viable pattern, yeah.
Okay.
Yeah.
So what's happening here is, as Mongo is getting data, we're dropping the data into EventBridge. And with this, I can then run, in this particular example, I'm using step functions. If you're not familiar with step functions, that allows you to orchestrate. And a lot of times you end up just configuring instead of actually coding. And I got to be honest, the most dangerous part of an application Eric Johnson's code. So you don't want me coding anytime. I know my title is developer advocate, but honestly, that's because they couldn't fit somewhat of a developer advocate on the card. So, but anyway, so the idea here is by kicking these events out to EventBridge, we can enrich the data. We can add some translations. We can add some audio files to this. I'm using comprehend to detect the language and making some choices in this. But then I can kick it right back into EventBridge. So what I've done is I set up MongoDB Atlas as a source event, and then I'm using MongoDB Atlas as my target for the events coming through. Now you're looking up over there. Would you change this at all?
No, I'm just looking up the key on the schema for the event that you receive. Is it includes object ID details, like the unique key for the event.
Yes.
The document that is triggering the event. So it's very simple for you to put an update back into the same document as an additional field or additional attribute within that document.
So when I was, and I love that, when I was building this, I spent a lot of time in your docs. It had full disclosure. I hadn't done a lot with Dynamo or with there it is. I just said with MongoDB in quite a while because AWS, I'm serverless. We do use DynamoDB, but getting back into it was a lot of fun. And it was the first NoSQL database I ever worked with, and watching where it was to where it is now, I was blown away. But anyway, I spent a lot of time in the docs, and one of the cool things is, I get the ID because that might be something you say, hey, can you? And I'll ask you, can you filter at the trigger and say, don't send this?
You can specify which fields you want to include in the trigger event.
Okay. Yeah. So I've already enriched it and I'm writing it back to Mongo Atlas. I don't want it to send it for another enrichment, right? So we can filter that out either at the Atlas. You can also do it at the EventBridge, where you can filter this. So we enrich it, we fill it. You can. There's a lot of machine learning. You can even write your own with SageMaker to make use of that. So with this, and I want to jump back, and I had this question in there, and this is interesting. Someone had asked me, is there a direct integration from Mongo to Lambda?
An event activation.
Yeah.
No, you would go through EventBridge for that.
Okay, all right. Yeah. So he was saying that he was actually invoking Lambda from Mongo. I wonder if he was using one of the functions.
If he's using triggers, then he could run one of our JavaScript functions,
right?
And from that JavaScript function, he could directly invoke
that's
Lambda using your SDK.
Okay, so the question I had, and I'll tell you my answer in a second to see what you think. When would I use this? When would I use that?
It's a good question. I mean, I would say use EventBridge if you want these rules. You want the ability to create and filter events using, for example, CloudFormation or CDK, to establish some kind of infrastructure as code-based control over your overall architecture. I think using Atlas App Services triggers is going to mean that you don't necessarily have everything defined inside an application manifest in the way that you might define it if you were using EventBridge and Lambda on the receiving end.
Yes, that's really good advice. I hadn't even thought about that. The IAC or the infrastructure as code is huge, and I'm a huge proponent, and I'm constantly talking about that. The one I also talked about is whether understanding synchronous versus asynchronous.
Yeah.
So like what you're doing, or not what you're doing, but what he was doing.
That would be sync invocation, right?
Exactly. A sync invocation, which is fine. There are times where look, I need to sync. But we always say, whenever you can go async, go async.
Yeah.
And so this is an asynchronous. The EventBridge both ways when you're triggering into AWS or you're pushing back to DynamoDB is an asynchronous, and you get some value out of that with EventBridge in that we have retry, we have error handling, where again you don't have to.
Yeah, you would need that in your Atlas App Services functions, wouldn't you? If for any reason that Lambda function couldn't be invoked, then you'd need retry, back off, maybe even a persistence store to hold and queue events that you hadn't been able to trigger. If you had to have reliably run at least once on those functions, that's something that you would need to build. Whereas EventBridge is going to provide that, right?
That's right. Yeah. That's exactly right. And so anytime you can configure and use something that's already built, battle hardened, tested.
Yeah, there's a lot of scope for mistakes with distributed system software engineering. If you can get somebody else to either engineer those mistakes out or be responsible for them, then, that's going to be a great idea, in my opinion.
Yep, I agree. Get rid of my messages here. There we go. And let's just right here in front of everybody, I'm going to do not disturb. What do you think? There we go. All right, so let me show you another pattern. This one I'm getting, and I kind of want to talk to this. This is what I was alluding to earlier. So in this one, I'm managing IoT devices. Excuse me, IoT devices with so the data is stored in MongoDB Atlas. Of course, I'm using serverless because I would. However, I want to interact with my mobile devices, and this is what I was talking about earlier, and I kind of jumped ship on you there. But with this, the idea is that as IoT sensors are sending data back, I'm dumping into MongoDB, but I'm updating my mobile applications with the state of those IoT sensors. And I'm just showing 8 here, but it could be 8,000.
One important thing I should say, to be absolutely transparent, is today we don't actually support Atlas Sync with Atlas Serverless.
Oh, okay, so good to know.
To use Atlas Sync and also to use event bridge triggers, at the moment you have to be running regular MongoDB Atlas instances. They're not currently supported by serverless, and actually this is a distributed systems challenge. If we're scaled down to 0, and then there is a sync event or an event needs to be sent, but we're at 0, then we wouldn't necessarily be able to do that in a timely manner for a customer. So there are one prereq, which is for Atlas Sync and for Event Bridge, you can't currently use MongoDB Atlas Serverless. You have to run a traditional dedicated instance, but we do have a free tier. So if you're starting small and you want to experiment, much like AWS, we've got a perpetual free tier on MongoDB Atlas, so you can experiment without any cost in doing that.
And I did that.
Yeah, but this is the kind of pattern that you would have for, say, connected vehicle or smart home.
Yeah, that's right.
Where you want to have the state of your device, like a digital twin, reflected in some sort of visual interface in your mobile application.
And as you control it, then it's synced back to the system. So it's a two-way sync going on. Yeah. And you can use a Lambda function. You can use IoT Core.
Yeah, and the way that our Atlas Sync works is, if you're in a dead spot where you don't have mobile connectivity or your Wi-Fi's down, it will reconcile and perform conflict resolution at the point at which the network bearer becomes available again. So you can switch your light switch on and off 10 times over here, and only the most recent update will be reflected as and when your connectivity gets reestablished.
Okay, so it wouldn't then later switch.
No, it doesn't batch. This is the value prop for Atlas Sync is conflict resolution and smart sync between the edge device and the cloud core and MongoDB Atlas core.
And that's huge. I think that alone, obviously there's a lot of value here, but that alone is a huge value in, I've even struggled with trying to.
Yeah, well, cloud computing for me, it's like avoiding undifferentiated heavy lifting means not writing software that someone else has written before,
that's
right?
Exactly right.
Is it a great idea for every mobile developer in the world to try and resolve their own sync issues and write their own sync transport bearer? I think probably not. I think the best option is to use a service where that problem's already been solved. Right?
That's right. Yeah, and that's I couldn't say that enough. You stop reinventing the wheel. Unless the wheel is your target to fix, stop reinventing it. Yeah. Excuse me. Apparently I'm going to cough it up here. So, all right, I have one more pattern I'm going to show you. See what you think. This one, when I brought it up, I saw people kind of go, why do I care about that? And so this one is protecting downstream infrastructure. And for most developers, this is not what we call sexy, right? This is like, okay. Because so the idea here is, as so Mongo's going to handle pretty massive amount of load, right? That's not where our latency is going to be introduced. But a lot of times as developers, we have to maintain legacy systems. I hate it, but it's true. And what we have are systems that were built in the 1990s that have not been updated, but that cannot be end of life. They have to stay around, but they can't handle the kind of traffic that's coming in. And so one of the ideas I thought is, and you actually alluded to this earlier, is if we drop this in and we drop, I'm totally using my hands. Well, you probably can't see me. If we drop this into Atlas and then it syncs and it goes to Event Bridge, and then what we do is the simple queue service is kind of the magic here. The Event Bridge is going to use simple queue service as a target, and they're going to queue up massive amounts of data, and then we're going to handle them in batches. Now the Lambda function, if that's our backend, that's going to scale. We obviously made that scale. But a lot of times, like ECS containers, if we're running our legacy system, most likely it's going to be on an EC2 container.
Yeah, I mean, there's always a question of what specialist compute resources you might need out here on the right-hand side. Let's just say you're encoding audio or video inside the schema within MongoDB Atlas. So you've got, pretty large base64 encoded binary data inside Atlas, which might be video or audio, and you need specialist resources here like GPU rendering or some other kind of specialist compute device that might not.
I'm just being realistic with your data, right?
Yeah.
Now, all right. So I'm going to ask a question. Can you store that?
Cases linked documents. So, there is a document payload constraint, but you'll find a lot of use cases can be solved by having parent documents which are linked to child documents that contain larger amounts of data. So that's definitely a common pattern that we see used a lot.
All righty. Oh, let's hide that. There we go. Sorry, I'm trying to get back to our window. Eric's being completely unprofessional here. So this is what one screen is looking like. Here we go. Let's stop the share. And oh, here you go. The share is stopped. Okay, good. Apparently, I was wondering if I didn't even stop it. But there we go. All right. So back at it here. The question I have on that one, though, so I want to follow up on that pattern. If you have a pattern like that, you wouldn't try to pass that data through EventBridge. You wouldn't send those huge
files. Because there's a payload constraint on the EventBridge, right?
Right. So 256K on that. What you want to do is you want to pass pointers, right?
Yeah.
Okay.
Document IDs or other fields in the documents that are unique that allow you to uniquely identify them and access them through the query interface. And it should also say those compute resources that you're going to be creating using SQS, they're going to be sitting inside a VPC, right?
That's right.
Well, you can spin up MongoDB Atlas and MongoDB Atlas Serverless inside a VPC with VPC endpoints using private links.
There you go.
All of your resources are hidden inside your private networking area. Yeah.
Faster, more secure. Yeah. You're not leaving the network. And that's the beauty of that is with the private endpoints. It is a fast, secure way of connecting.
Yeah, and you can use like SQS FIFO queues to ensure that you're only delivering each one of those queue messages once, right, and processing them in the right order, so you can have whatever deliverability characteristics you want to make sure that you're processing those payloads reliably.
Right. Okay. So tell me this: what patterns do you suggest for this? What are some of the things when you talk about EventBridge? What are some things that you see as high quality patterns?
Well, the ones that you've shown there are great. I think that's excellent, and it basically goes down to the three that I described. So, event-driven model, pushing through EventBridge, and then processing the payload of the change stream over in your Lambda function using programming languages of your choice, and then on the inbound, supporting the event-driven back-in, either with synchronous access to MongoDB Atlas from inside your Lambda functions or via Kinesis Firehose if you've got large-scale deliveries.
Okay. Yeah. Those are good ones. All right. Well, with that, I think, what else? Do you have anything else you want to throw out?
No, I think we're covered. Okay. Live stream of Mark Porter's keynote, so that's our CTO.
Yeah.
You can catch it on the MongoDB official YouTube later on today. So if you want to watch that, it's at 2 p.m. Eastern. So in about 30 minutes, Mark Porter will be up. But if you don't know, he was the original GM of Amazon Aurora, so definitely worth a watch. And we have a few little bits of developer goodness to come this afternoon as well. A few more launches for you, so join us for that.
All righty. With that, normally this is an hour long. You notice we're cutting it to a half hour. We're both running elsewhere, and so I appreciate your time.
Yeah, we've got to give Mikey's studio back as well.
Yeah. Thanks for working with my screen sharing issues. So with that, next week, back same time, same place. Serverless office hours every Tuesday at 10 a.m. Pacific. No telling where we'll be. The actual developer, I think, and I'll check with Julian, the actual developer advocacy team is all over the world next week, actually. So we'll have to announce what's coming up next. So we'll see y'all later. Ian, thanks again. I appreciate it.
Great to see you again. See y'all. Bye-bye.